Hello gang, welcome to another edition of This is Your Life in Mathematics class. Anyway, today we're going to cover the derivatives of exponential functions as well as review some of the rules around how logarithmic functions can be manipulated. Not quite sure why we wait so long to introduce this. It seems like it must be very complicated, but in the fact it is actually very, very simple and straightforward. So a quick review on exponential functions. Here's the graph of an exponential function, the natural exponential function, e to the x. There's a few things that you're supposed to notice. It crosses the y-axis at 1. That is asymptotic to the x-axis. That is, it approaches the x-axis but never actually gets there, which makes the domain and range, the domain would be all real numbers, and the range would be y greater than 0. Okay, so it talks about how the curve continuously increases. So the slope of the tangent line as you move across continues to get larger and larger. So from this observation, it looks like to find the derivative of e to the x is in fact just e to the x. So the derivative of e to the x is itself. It is the function that has its own derivative as the derivative function. Really kind of cool, kind of interesting. Now if e is raised to a power of a function, and we denote that usually with the with u, what we do is we take e to the u, so we take itself, but then we have to multiply it by the derivative of that function, so the derivative du with respect to x. So let's apply these rules, and oh wait, first let's talk a little bit about why this is true. And so I pulled this proof from Ron Larson's calculus book, the 9th edition, and this is a very simple, straightforward proof showing how the derivative of e to the x is actually itself. Okay, now for the first example, why don't you go ahead and try this before I walk through it, so go ahead and press pause. Okay, so hopefully you've tried this. You should recognize right away that this is actually a chain, a product rule application. So we've got a couple of rules in play together. So first of all, we take the derivative of the first function, multiply it the second function as it is, all right, and then we take the first function as it is and multiply it times the derivative of the second function. All right, and that's when we get this. All right, so if we simplify, we get something like this. Hopefully you feel that this is super, super easy, like maybe even like scary how easy it is. We'll move on to the natural logarithm function. Now the natural log is when a log is base e. So when you have a log base e, we denote it as the natural log, or ln of x. And we can see that this is the inverse function of e to the x. All right, so it's flipped over the y equals x line. That's how we can see that two functions are inverses of each other. All right, and down here there are multiple forms of writing the same thing. By writing e to the x equals a, we can change it into this form, and it's exactly the same thing. All right, and because they're inverses of each other, e to the natural log of a is equal to a, and also the natural log of e is going to give you a also. All right, so let's see this. Let's review some rules. All right, so if I have the natural of the product of two terms, we can split that into two separate natural logs, separated by a plus sign there. So hopefully these rules look familiar to you. Another thing is the natural log of 1 is 0. All right, so the exponent of e that gives you 1 is 0, so that should make you some sense. the natural log, so log base e, the exponent of e that gives you e is 1, right? E to the 1 is just e. So these rules should make sense to you also. This is the famous change of base formula also. Now, these rules were written with natural log here, but you could have put any log here. So log base 10, log base 2, whatever. These rules all still will apply. So now the derivative of natural log is also very easy. It's just 1 over x. And now if we take a derivative of the natural log of a function, right, it's going to be 1 over that function times the derivative of that function. All right, so very similar to the derivative of e to the x. So let's go ahead and try an example of the derivative of natural log. So pause and try this example. Okay, so the first thing that you should know with all of these problems is there's probably an easier way. There's probably an easier way of doing this. So immediately when I see this, I'm thinking, okay, I'm going to have to do product rule. I'm going to have to use the natural log rule and the product rule, and I might have a mess. But there's actually an easier way to go about this problem by using the natural log rules. All right. So we said before that if I have the product, what I can do is I can split this into 2 natural logs added together. So we see here that we can split this into the natural log of x plus the natural log of e to the negative x. Now I can take this a step further because I know that these are inverses of each other. So this whole term simplifies to just negative x. Now when I take a look and I'm required to derive this function, it's much easier. I can just derive each function one piece at a time and arrive at this. Okay, so this is the answer. What would have happened if you didn't see this shorter, simpler way of doing it and you went ahead and used the product rule? Well, it gets much easier, much messier, but you should arrive at the same answer. So here we go. We do 1 over the function that's given, and then we have to multiply times the function, the derivative of this function. Well, this is actually a product, so I have to use the product rule here. So I have the first times the derivative of the second, right, which gives us this term, and then I have the second times the derivative of the first, which is just 1, right? So I get this. I can do some simplifying here, and then again here. And you'll see that these two answers are exactly the same. Okay, so that's using the derivative of natural log. Let's try one more example. Here's one I want you to try, so go ahead and press pause. Okay, hopefully you're starting to get the message that every time you try one of these problems, that there's probably an easier way of going about it. Now, it looks like here that you're going to have to do the quotient rule. But as it turns out, what we can do is we can do some simplifying. We have, we can split this into 3 different natural logs, right? We have the natural log of the numerator minus the natural log of the denominator, which can be split into the natural log of this plus the natural log of this. All right, and if we simplify, we get something like this, which is much easier to find the derivative of. We just do each piece, and it looks like this. Now, if you didn't recognize this and wanted to do the quotient rule, you're going to get something much more nightmarish. And I went ahead and started it, and then I just really didn't care to go through all the algebraic manipulations, but eventually you would have gotten to the same answer. So just keep in mind that most of the problems that you receive that look complicated like this, there is some manipulation that you can do up front. Hopefully you'll be creative enough to see the paths that you can take to make it simpler and make things much easier on yourself. All right. Hope you got a lot out of this lesson.